Okay, so we wrapped up yesterday. You guys, why don't you click them all closed, please? And I'll make this as quick as possible. I had one board work problem, but I'll let you guys vote on it. If you'd rather just jump into the assignment, we can skip the board work on the one we have today. So this is one you guys worked on yesterday. Let's just remind ourselves how we clear fractions. Now, I want you to look closely at this situation because we're going to compare this to a couple different examples following this. Notice here, this is a pretty straightforward example of clearing fractions because we've got four terms. Remember, in math, factors are things that are multiplied, terms are the things that are added or subtracted, right? So I've got a total of four terms, two on each side of the equation, and each term is fractional, okay? Make sense? But nothing's being distributed. It's pretty clean. So clearing fractions is very straightforward. What do? We want to find a common denominator. Now, finding the common denominator, remind me what our strategy is here. We're going to look for multiples of which denominator until we find a winner? 24, good. So we'll just step our way through the multiples of 24 until we find one that's compatible with the other denominators. 72 is the answer, good. So we could distribute a 72. And remember now, because we are clearing fractions, we handpick that number so that all the denominators will divide evenly into it, right? So what's my special trick I showed you guys yesterday for making this easy? What do? Okay, good. We're going to reduce the fraction first and then multiply what's left by the numerator. So 72 over 9 is 8 times negative 1n is negative 8. Oh, that looks terrible. Negative 8n. 72 over 8 is, so we get plus 9 equals 72 over 6, 12, times negative 5n is what? Negative 60n. And finally, 72 over 24, 3, times negative 5 is negative 15. And from there on out, I mean, that's no big deal, right? We won't even mess with that. You guys can do all that stuff. Now we've got it into a simple linear equation with integer coefficients. We just collect the like terms collect the ends on the side where we get a positive coefficient and isolate the end, right? And you guys will get plenty of practice with that. I won't even waste your time on that one. Okay, what's different here? Okay, there is some distribution going on here, right? I've got some fractions that are out in front of these quantities. So really there's a couple different options we have for taking care of this. One thing we could do is just distribute the fractions to give us a problem just like that one, right? Everybody agree? If I distribute all those fractions over those quantities, I'm just going to get a bunch of terms, fractional terms. And then I can just clear fractions like we did in the last two examples that we've talked about, right? Do we have to do that? Not necessarily, but we have to be careful if we don't, okay? And keep in mind, you always can just distribute, and if you're at all unsure, especially on a test, just distribute. Just distribute and clear fractions from there. Okay, how could we avoid that though? What we see how many total denominators? 2, okay? So what is the the least common denominator of those fractions? It's 4. Okay, so we could just distribute a 4. But when you do that, again, you have to be a little bit careful. When I distribute the 4, where do I distribute it to? Okay, so I'm going to distribute it there. Do I need to distribute it to the y plus 8? No, I don't. I don't, because I distributed it. This is the first term, right, in the expression. Here's the second term in the expression. Here's the third term in the expression, and there's the fourth term. I'm just going to distribute it to each of the 4 terms, and that's it, right? What is 4 times 1/2 times y plus 8? When you multiply, we talked about the properties of real numbers, right? When we multiply in pairs, two at a time, right? So the easiest way to do this would be to multiply the 4 times the 1/2 first, and then whatever I get is going to be distributed, right? Make sense? Okay. If I tried to distribute the 4 to the 1/2 and distribute it inside this quantity, I would be like double distributing there, and that's not correct. Make sense? This is the same concept as why if you're multiplying 2 times 3 times 4, what's the answer? 24. You multiply the 2 times the 3, but you wouldn't multiply the 2 times the 3 and the 4, right? Make sense? That would be incorrect. You multiply the 2 times the 3, find the product, and then multiply that times the 4. Same thing here. Okay, so if I distribute the 4 to the 1/2, what's that give me? 2. Good. And then I get 2 times the quantity y plus 8. The 4 times the 1/2 just gave me a 2, didn't it? Okay. Now I have to distribute the 4 to that term, and what's it give me? 20. Equals, what's going to happen when I distribute the 4 to that term? Yeah, okay, it's going to cancel the 1/4, isn't it? 4 times 1/4 gives me 1. So I'm just left with 8y minus 14. And I really don't need those parentheses anymore, do I? Because now only a 1 is being distributed. So I would just get rid of those. And then finally, when I distribute the 4 all the way over to that -7, I get, okay. And now I've got a pretty straightforward linear equation, right? What are the steps I would go through to solve this? Okay, what do I have to do first? I'd have to distribute the 2 over this quantity. Then I would, what? Okay, but how do I do that? I'm not ready to isolate yet because I got to combine like terms and push the y's to one side or the other depending on where the coefficient of y would be positive, right? And then, once I push the y to one side and I have a single y, then I could use inverse operations and isolate the y. Give me 1 to 5 on that process. Okay, so would you guys rather just skip the algebra steps on that one? Okay, that's fine with me. You'll get a chance to practice. So then maybe we don't need to do this one. This is the one I had set up for you guys to do, but would you rather just skip that and get into the assignment as quick as you can? That makes sense. I feel like you guys need some work time. Okay, last one. Really not a big deal. What could I do here? Because I don't want to deal with those decimals either. What could I do? I mean, I could, but I really don't need decimals. Decimals are just like fractions, right? I mean, it's like base 10 fractions essentially. But I'd rather have integer coefficients than decimal coefficients. So can anybody think of something I could distribute here to make this look a little easier? Yeah. Why 10? Okay, yeah, because look how deep the decimal places are on this. I've got decimals that only extend to the tenths place, so multiplying by 10, both sides by 10 would effectively just shift the decimals one to the left of all the coefficients, wouldn't it? Everybody see that? Okay, so let's walk me through that process then. So if I distribute 10, what am I going to get there? Did I say one to the left? I meant one to the right with the decimals. Yeah. So 3x, what would this be? Minus 60 equals 11x, good, minus, and again, that's pretty easy now, right? Now we've got integer coefficients, simple linear equation. How about this one? What would I do on this guy? Multiply by 10 again. Okay, I want you to talk me through this one though. Be very careful. Okay, so what's that going to give me? Plus 4 Okay, 6. So now I distribute the 10. When I distribute to this term, I'm going to multiply the 10 by the 0.6, but whatever I get still has to be distributed to the y plus 4, right? Give me 1 to 5 on that. Does that make sense? Okay, and then from there on out, we would just distribute the 6, collect like terms, isolate the y, and solve, right? Okay, you good? Jump into it.